In this video, we're going to show why all these shapes can never be cyclic quadrilaterals. The first shape we're going to assess is the rhombus, which is a quadrilateral where adjacent sides are of equal length, which means that all four sides are the same length, but none of the internal angles are right angles. So they're either obtuse angles, which are larger than 90 degrees, or acute angles, which are smaller than 90 degrees. So let's give the angles some labels. And now we can show why a rhombus cannot be a cyclic quadrilateral. One of the first things I want to point out is the nature of the top right and bottom right angles of the rhombus. If I draw a vertical line from the top right corner downwards, because this line is perpendicular, the entire angle from the top of the rhombus to that line is 90 degrees. And you can clearly see that the angle B is less than 90 degrees. So B is an acute angle. So B is less than 90 degrees. Now I'm going to draw another straight line from the bottom right corner vertically upwards. And because this line is perpendicular to the bottom edge, you can see that the angle between the edge and the line we've just drawn is 90 degrees, a right angle. And you should be able to clearly see that the angle D is larger than that angle. So D is greater than 90 degrees. Let's make a note of that as well. So the angle D is greater than 90 degrees. Now, if you know your parallelogram rules, you'll know that adjacent angles are supplementary. That is, they add up to 180 degrees. So that means the two top angles, A and B, must add up to 180 degrees. A plus B equals 180 degrees. Now, if the rhombus is a cyclic quadrilateral, then opposite angles C and B, or A and D, must add up to 180 degrees. So let's suppose that that is true, that A plus D, which are opposite angles, add up to 180. That means A plus D equals 180 degrees. Now, if we subtract A from both of these two equations, we will get that B equals 180 degrees minus A, and D equals 180 degrees minus A. And that tells us that B equals D. So if A equals D, that is, the opposite angles in the rhombus are supplementary and add up to 180, then it means that B equals D. But that can't be right, because earlier we saw that B is less than 90 degrees and D is greater than 90 degrees. So B cannot be D. One of these two equations is incorrect. Well, this one, the top one, comes from this one, and we know this has to be right because these two angles are adjacent, and adjacent angles in a parallelogram add up to 180 degrees. So A plus D must be wrong. The opposite angles in the rhombus cannot add up to 180 degrees. By the way, the exact same rules apply to the rhomboid. It is a parallelogram where none of the internal angles are right angles. B and C, which are opposite angles, are both acute, so they're both less than 90. So adding them together will get you less than 180, and the sum of the other two opposite angles must be greater than 180. So we don't need to show the workings for this example because they're exactly the same as the rhombus. The next shape we're going to deal with is the right-angled trapezoid. Let's label the angles, and since both B and D are right angles, let's note that there. So B equals 90 and D equals 90. Now, because both B and D add up to 90 degrees, then B plus D must equals 90 plus 90, which equals 180 degrees. Now, because B plus D are right angles and add up to 180 degrees, and the sum of all angles in the quadrilateral add up to 360 degrees, the remaining angles A and C must add up to 180 degrees. So that means that A plus C equals 180 degrees. But we can get an idea of what type of angle C is by drawing a straight line from the bottom left corner vertically upward. The angle between the vertical line and the bottom of the trapezoid is 90 degrees. We can clearly see that the angle C is smaller than that angle, so C is less than 90 degrees. Let's make a note of that. So now that we have this information about the right angled trapezoid, if it is a cyclic quadrilateral, then the opposite angles are supplementary. And that means the angle A plus D would be 180 degrees. So let's suppose that's true. A plus D equals 180 degrees. Now if we take these two equations, we get that A plus C equals 180 degrees and A plus D equals 180 degrees. So if you add C to A, you get 180, and if you add D to A, you get 180 degrees, which means C must be equal to D. But again, do you see the problem here? We just realized that C is less than 90 and D equals 90. So C equals D cannot be true. So one of these equations is wrong. And we know A plus C must be true because B plus D are right angles and they add up to 180 degrees. So A plus C must add up to 180 degrees. So A plus D must be wrong. A plus D does not add up to 180 degrees, which means opposite angles do not add up to 180 degrees. And that means that this shape, the right angled trapezoid, cannot be a cyclic quadrilateral. This is the next trapezoid that we're going to examine to see if it can be a cyclic quadrilateral. I'm not going to give it its name yet. The first thing we're going to do is examine the bottom two angles, the angles at the base. If we draw a straight line vertically from the bottom left of the trapezoid, now you should be able to see that the angle between the vertical line we just drew and the base of the shape is a right angle, and that the angle C is smaller in value than the right angle. C is an acute angle less than 90 degrees. Now let's focus on the angle D and draw a straight line from the bottom right vertically upwards. And again, you should see that the angle between the vertical line and the base of the shape is a right angle, it's 90 degrees, but the angle D is larger than the right angle, so D is larger than 90 degrees. The fact that C is less than 90 and is acute, and D is greater than 90 and is obtuse, means that this is an obtuse trapezoid, because in an obtuse trapezoid, at the base angle, the longer base, one of the angles is acute and the other one is obtuse. So let's go about proving why this shape cannot be a cyclic quadrilateral. We can begin by finding the sum of the angles A and C. If I start at the top left corner of the shape and extend out so that the top edge goes further, we know that the top and bottom edge are parallel, and the diagonal line here acts as a transversal, and you should be able to see a Z shape here. When we have these two parallel lines and a transversal intersecting them diagonally, the corners of the Z shape are called alternate angles and they have the same value. And that means that this angle is the same as C. The sum of angles across this top line is 180 degrees, so A plus C must equal 180 degrees, which means that the top left and bottom left angles add up to 180 degrees and therefore are supplementary. Now, if this trapezoid is a cyclic quadrilateral, then opposite angles must be supplementary and therefore add up to 180 degrees. If we find the sum of A and D, they must be 180 degrees. So A plus D must equal 180 degrees if the shape is a cyclic quadrilateral. So if we add C to A and it gets 180 degrees, and we add D to A and it results in 180 degrees, that means that C equals D. And again, we have the same problem as before. We've shown that C is an acute angle, it's less than 90 degrees, and D is an obtuse angle, it's greater than 90 degrees. So it's impossible for C to equal D. So one of these two equations must be wrong. We showed that A plus C has to be 180 degrees, which means the opposite angles A plus D cannot be 180 degrees, and hence this shape cannot be a cyclic quadrilateral. We have one final shape to examine. Instead of showing the shape this time, I'm going to construct each edge separately, which will help us understand a little bit about the angles. The first thing I'm going to do is draw parallel lines for the top and bottom of the shape, and then I'm going to draw a line, a diagonal line on the left hand side which intersects both the parallel lines. If you know your parallel lines theory, you will remember that consecutive internal angles that are on the same side of the transversal are supplementary. So if I put angle markers in, you can see that these two angles are consecutive, they are one after the other, they're both on the same side of the transversal, and they are internal. So these two angles are supplementary. Let's give the top angle the label A and the bottom angle the label C. And since they are supplementary, let's write that down. Now I'm going to add a right hand side edge so we can get an understanding of the top angles compared to each other. Now if you look at this shape, you can see that it's symmetrical. The right hand side is a mirror of the left hand side, and that means that the top angles of this shape are equivalent and the bottom angles of this shape are equivalent. The line of symmetry is a vertical line that runs from top to bottom. This shape is called an isosceles trapezoid, but that's not the shape I want to consider. I just wanted to show the relationship between the top and bottom angles of each side. Let's remove the angle markings and the line, and we'll add in a line at a slightly different angle. Now hopefully you can see that this shape is no longer symmetrical, and what that means is that the top right angle is no longer equivalent to the top left angle, and the angles at the base are no longer equivalent. Let's label the top angle B and the bottom angle D, and hopefully you can see that this shape is no longer symmetrical. The right hand side is not a reflection of the left hand side, so the angles are different. A is not equal to B. By the way, this shape is called an acute trapezoid, and that's because both of the base angles, the longer base angles, are acute. C is less than 90 and D is less than 90 degrees. Now suppose we don't know if the acute trapezoid is a cyclic quadrilateral and we want to show that it is. Then again we have to show that the opposite angles add up to 180 degrees or are supplementary. Now let's say we believe that B and C, which are opposite angles, are supplementary. Well then that means B plus C must be equal to 180 degrees, and that would prove that this is a cyclic quadrilateral. But if we consider these two equations, you can see that if you add A to C, it results in 180 degrees. But if you add B to C, it results in 180 degrees, which means that A must be equal to B. But we already showed that A cannot be equal to B because this shape isn't symmetrical. So one of these two equations must be wrong. And we know that A plus C must be correct because they are consecutive internal angles on the same side of the traversal. So they must be supplementary. In other words, their A plus C is 180 degrees. So B plus C, the opposite angles, cannot be 180 degrees. And in that way, we've shown that the acute trapezoid cannot be a cyclic quadrilateral